12-tone music is based on this idea that you use all 12 notes before you repeat them again. Your tone row is this bass row where you select the order of the notes. The octave doesn't matter, the duration of the note doesn't really matter, it's just this tool that you start with. You're going to choose what order the notes go in. How many possibilities does that kind of ordering exist? 12 factorial. How many choices do I have for the first note? 12. Okay, I can't repeat, so how many choices do I have? 11. 10. Factorial. And that's about 479 million. That's a lot of different possibilities. And this is just if you use each note one time. You do operations to the row and then you generate a piece of music. There are 4 basic operations. You can have prime, which is the original order that you chose. Retrograde is you reverse the order. Inversion is you invert the intervals, which is a little bit different than this kind of inversion, but I'll show you that. And then retrograde inversion is doing both the inversion of the intervals and playing them backwards. I'm going to give you a prime row. Prime is like your original order. 11, 10, 7, 1, 3, 0, 6, 4, 8, 5. How do we do retrograde?
13.
Right, you do them backwards. So you would write it as 5, 8, 4, 6, 9, 2, 0, 3. This inversion is just invert intervals. So if you went up here, we went down 1 semitone. So we're going to go up 1 semitone instead. So you start on the first note. You go 11, 0, 3. How did you guys do this? Explain it to them.
Because going from 11 to 10, you go down 1. That means in the inversion, you have to go up 1.
Right. Here it's minus 1. What's the next one? 10. Good. 8. What we did before was we took this whole thing, inverted it around 1 note. Here we're inverting every interval. Let's just make one up as a class. So give me an order of numbers that you want. You have to use each number once.
8.
7, 9.
Like, this is what? G sharp. That's what you guys came up with. So let's do an operation. So what's retrograde? Backwards. So I'll play this backwards. 10, 6, 11. So I'll play forward and then backwards so you can see how they sound. So I use the same rhythm. It's hard to hear. And that's the point of this, that it's not that easy to tell, oh, the first thing I played is the same thing as the second thing, but backwards. And that's kind of the point. The idea is like, okay, we do these different operations where we're not just randomly writing another phrase after the first phrase. The second phrase is related by being backwards, but maybe you can't hear that so easily. Okay. The next operation is inversion. So in this kind of inversion, you invert the intervals, meaning instead of picking a note to invert around, we're going to invert the intervals. 8 to 9 is +1, right? So instead of +1, we go -1. So start on 8. If we go -1, it's 7. -8. So now instead of going down 8, we're going to go up 8. 7 + 8 is what?
15.
15 mod 12 is? 3. Okay, good. Okay, let's go over the notes. G sharp. We're starting on the same note, but we inverted all of the intervals. Where does it sound similar? There's actually one area where it sounds really similar.
I think where we did the 5, 6, 11, 10.
Yes, it's the end. Yeah, the end is this. And here is. Yes, the actual notes are the same, but it's also that the relationship, like you have the 6s and the 5s being close to each other. So retrograde inversion is going to be what? It's just the same thing backwards. So 6, 10, 3, 6. So I'll play the inversion and then that one. So in 12-tone music, you do each of these operations and you use each row once before you repeat it again. It's better than just randomly choosing new phrases and new notes because there is some relationship. Like, shout out when I go to a different row. So So some last questions for you. How many forms of a prime row exist within a row or a set class? You can repeat nodes, you can change the durations, change the rhythm, inverted, and retrograde inverted. That's 4 right there. So you get how many forms with one row? 12 times 4. 48. There are some duplicates due to enharmonic nodes, like C sharp and D flat are the same and so on. But you take this number of possible tone rows that we have, but you divide by 48 duplicates, you end up with approximately the number of unique tone rows that exist, which is 985, 920, which is approximately this divided by 48. So I thought for the rest of the time, you guys would try to do this. You can write a row and write out the other 3, retrograde, inversion, and so on, and try to play it. Or if you're more interested in like coming up with a melody and doing transposition, hearing how that works mathematically, but then at the end we're all gonna play.
It's a joint effort. You said I killed it.
These two groups came up with a really interesting idea of playing the prime and the retrograde together at the same time. Now, they do the same thing, but it sounds totally different. Great. Same idea, they took 3 notes, but why did theirs sound different? It's not just the notes that they chose, it's the intervals between the notes. And they chose notes where the intervals started out a lot closer together, so it sounds a little crunchy. Do you want to explain to class what you did?
We did the inversion one, and then we used the number 7, so we like 7 minus 0.
So inversion around 7. The original one sounds like this. Now, inversion around 7 is like this. Okay, ready? I did the other one, which was nice.
I just made a little melody out of these.